Welcome to all of you. Today we are going to be discuss about very important classification algorithm, that is a random forest. I have chosen two different example for the understanding of this random forest. So in one of the video I will discuss about how this random forest basically works, and in subsequent video we will try to see the parameters which we can give, and how the impact of those parameters are happening over the random forest. That kind of understanding we will try to inculcate.
Now let us discuss about the random forest. So we have already understood about the decision trees and how they can be used in the machine learning. Now let us think what happens when there are several decision trees which are contributing to various final result. So in that case we have to consider about what maximum number of trees are voting for. For example, when let's say 7 tree out of 10 are saying yes, right, and let's say 3 are saying no, then we have to decide the final result to be yes. In this manner, basically the majority voting will lead us to the better accuracy in the final result. Now we see this group of trees, generally we see a group of trees in forest. So in a similar manner, if we take a group of decision tree, we can call that a group of random forest, right? So that is the idea behind this random forest algorithm. Now the main aim of constructing this random forest is to arrive at a better accuracy in the predictions. Now this basically this random forest model is called as a iterative model, since it involves a group of this decision trees in arriving at a final result. So in case of random forest, how data is going to be distributed between the various model, that is the main concern. That actually we have to understand how this data set we should pass among the different decision tree. So that part firstly we have to understand. So hopefully we have learned it. Now let us quickly revise the concept behind that, right? So the famous method is this bootstrapping. So let us imagine a data set that contain a group of rows. Now each row contains some columns from where we take only those columns that contribute for our let's say for our analysis. Now when we represent the relationship between this column on a graph, it is shown as a data point. Thus basically this data point contain many, this data set contain many number of the data point. Suppose we want to create a sample, right? Sample from this main data. That means we want to create a subset, this subset of data point from this main set of data. Now concern is how can we do this, right? So first of all, we must decide the sample size. For example, let us take the sample size is equal to 5. That means we want to create a subset with a 5 data point, right? Now we have to collect 5 data point from this main set of data and put them into one subset, right? So this can be done in basically two ways, right? In the first way, we can actually remove this data from the data, this data point from the main set and put it into this subset. That means when a data point enters into the subset, this was removed from the main set and hence it is not going to be available in the main data set. Now the data point removed from this main set are not replaced by any other data. That is the important thing which we have to understand here. So this is known as creating the subset without replacement, right? Now here we are creating basically this two subset of the data. Now data point are included in the subset number 1 were removed from this main data, and hence they cannot be appear into this subset number 2, right? So that is a one way. Now there is another way for creating this subset of data. Here we are not actually removing the data point from this main data set. We are copying the data point from the main data set and put them back into this subset, right? That means the original data point are still available in this main data set, and their copy only are used in creation of this subset. Now see, in this case, the same data point can be used to create various subset of data, right? See here, there is a duplicacy, right? There is a same data point is available over here. Now here we are basically creating this two subset. The first subset is created by copying the 5 data point from the this main data set. After creating the subset also, the same data point are still available in the main set, and hence they can be used either fully or maybe the partially in creating the second subset. So this is known as creating a subset with replacement of the data, right? Here we are doing the replacement. Now the important the takeaway point from here is it is possible to create subset of data from the main data set. So this can be done either with a replacement or maybe without replacement. So this process is actually known as the bootstrapping, right? That means we are creating a subset from the main set of data, right? That is the meaning of bootstrapping. So generally in bootstrapping, we do certain things like we have to decide the size of the subset of this subset which we want to create. We create the subset with or without replacement, and we can repeat these steps to create the several subsets, right? So that is the idea. Now through this bootstrapping, now it is possible to create various subset of data, right? So that we have seen. Now this each subset of data, once we have created from this data set, that can be feed to one of the decision tree, right? The another subset we can feed to the another decision tree, right? And subsequently the different subset is going to be fed to the different set of decision tree, right? So that is the idea. Hence here every tree receives the different data, right? So this bootstrapping is a technique basically which is used to create a subset from this original data set, and that can be used by decision tree in this random forest model, right? So that is the overall idea about this bootstrapping. Now there is one more concept that is called as bagging, right? So this is the concept of bagging. So basically in a machine learning model, as we know, it uses a group of other model, right? Let's say if any machine learning model uses a group of other model, then there is a chance of high variance, right? So if you see this picture, so in such kind of situation, there is a chance of high variance in the result. So basically to reduce this high variance, we can use a technique called bagging, right? This bagging is also known as bootstrap aggregation. So this is nothing but we are going to be apply this bootstrap procedure to the machine learning model. Basically the purpose is we want to reduce the variance, right? So in bagging, we use this bootstrap procedure to create a number of subset of data randomly with replacement, right? With the replacement. Now we are going to be create the subset is done from the the training data set, right? So this each subset of data basically is feed to the model as a training data X. Now the model is trained with this data, and Y is the output which we obtained. Now see, after getting this output from the different model, the mean or average value of all the output from this model will be the final result, right? So that is the idea. Now, since this bagging provide the data set with the replacement, the same data again and again used by the model, and thus variance can be reduced. So that is the advantage, right? So the main advantage of this bagging is to reduce the variance, or you may say the overfitting of the model, right? One more idea which is very important to understand the concept of random forest is the boosting, right? So basically in boosting we focus on how to reduce the variance or overfitting. So sometimes the model may perform well with the less variance, but it may not be able to provide the better accuracy in predictions, right? So that may be possible, right, in one of the situation. Now to improve the accuracy of the model, we can use boosting technique, basically, which is an extension of the bagging, right? Now in boosting also, we will take the bootstrap procedure to supply the subset of data, but this time this subset are created without replacement, right? That is a highlighted point over here. That means data once used in this subset is not given to the another subset. Now this subset does become the input to the model, input to the each of the model in this complex final model, right? Now let us take that first subset of data is feed to the first model. Suppose the model is classification model, then it takes the data as a training data and classify the data. In this phase, let's say some data point may not be classified correctly and some data point may be misclassified. Some are classified correctly and some of the data misclassified, right? So in the next step, the second subset of data is created from the main data set. In this data set, previously misclassified data, this misclassified data point are basically added, and then this subset of data we feed to the second model, right? Now the second model may classify some of those previously misclassified data point correctly, right? So this that is going to be classified correctly this time, but still there may be chance that some second model also will do some sort of misclassification, right? So again in the next step, the third subset of data is created from this main data set, and then the misclassified data from the second model are also added into this subset, right? Now this subset is feed to the another model, right? So that is how actually this boosting work. So in this way, we have to repeat the steps with the several subset of data, and we have to observe that this misclassified data points are classified by this misclassified data point are classified by majority of this the models, right? And finally we take the majority vote. That means in case of overall data, the classification done by the majority of the model should be considered as the accurate result, right? So that is the idea behind it. Now the model which are involved here, right? This model which are involved in this this complex model basically is called as ensemble learner, right? So they are basically called as ensemble learner. So the word basically this ensemble means the group, right? So in the same fashion, combining the individual model to make the better complex model is called ensemble learning, right? So that is the idea behind it. So you may say that ensemble learning, it is possible that individual model comes together and bring forth a new model that is more accurate and the more useful. So we have several ensemble technique like AdaBoost and gradient boosting. So that we may discuss later. Now let us discuss about this random forest. So this random forest, or you may say the random decision forest, is the basically algorithm that operate based on the several decision trees. So basically it uses the multiple decision tree during the training phase, and the final result is decided based on the decision given by the majority of the decision tree, right? So that is the idea behind it. So basically this random forest may use 10 or 100 decision tree. Since there are several decision trees, each tree may give a different decisions, right? So again, the decision given by the majority of the trees is taken into the account, right? So that is a voting concepts is there. Now basically this random forest is used in a classification problem, where we have to classify the, let's say in our case there are digits written by the human being into available, 10 digits are available over here. So that we will try to see how this decision tree classifier will help us for doing these classifications, right? So now one more important part we must understand, that this random forest uses the Adabos technique internally that help to send the misclassified abnormal data point from one decision tree to another decision tree, so that they refine the model and finally classify the data properly, right? So basically in this fashion, random forest is useful to reduce the impact of the overfitting, right? So by that way, this technique will lead to the high accuracy of the model even in the the testing phase. Now let us remember that random forest uses the several number of decision tree, and hence it works better compared to the obviously to the single decision tree. Also, all decision tree in random forest work in a the series, right, to produce the output. They are quite useful when for the large volume of the data. So that is a again important understanding which we have to develop over here. But one more, there is a main disadvantage of the random forest is that it may take more time to predict the result. So this is because it has to wait till obtain the result from all the decision trees, right? So there is this time complexity. Here time it required the more amount of time. That is the meaning of that. Now to understand how to construct and use this random forest, let us classify this human written digits with the help of this random forest classifier, right? So here this digits, basically this digit data set in this scikit-learn package contain basically 10 different classes of digits. There are around 180 samples, so simply you can download it from the sklearn, and there are total number of samples are around 1800, 1797, right? So now to load this digits data set, we can simply call this load digits function, and that is available in this sklearn.dataset module, right? So now here this resultant object digits is the bunch object that is similar to the dictionary in Python, that is store data in form of key value pair, right? So when key is given, corresponding value can be picked up. For example, this digits dot target underscore names is the key, and the corresponding value it gives in all target, right? So basically this 0, 1, 2, 3, 4, 5 in form of the array. To see the column names, right, we can use this dir function over the digits, right? So this is the column name over here. Now to display image, we can use this matshow, this matshow function, which is available in this pyplot module of matplotlib package, right? So let us display the first 10 digits image using this for loop, right? So these are the 10 digits which we are having, right? So these are the value which we are having. 0, this is 1, this is a 2, 3, 4, 5, 6, 7, 8, and this one is 9. Now if we want to create a data frame from the digits object, we can pass this object to data frame class object, right? So here we are importing pandas as PD, and then df pd.dataframe digits.data, and this is df.head. So if we observe that each row basically contain 64 values from 0 to 63 corresponding to the data of one image. Now this 0th row represents the data of digit 0, and the first row represent the data of the digit 1, right? In this case, this above data frame does not have the the target, right? Target column. So now what we have to do, we have to add it, right? So here what we are doing here is we are adding it. We are adding this target data frame to the target data to our data frame by executing this statement. Now we have got this full-fledged data in our data frame df, right? Now let us divide the input and target from this data frame and take them as x and y respectively, right? So this is our x and this is the corresponding y which we are getting from our data frame df, right? So here this df target indicate the series object. This is basically this is converted into 1D array using the dot values attribute. Now let us split the x and y data into 80 and 20% of test data by using this trend test split function like this, right? Now here, now the data basically after doing this, now our data is ready. Now we have to construct and train the random forest model with this data. Now see, this random forest is constructed as a object of random forest classifier class that is found in ensemble module of this sklearn package, right? Now see here in this criteria of random forest, how many decision tree are used by default. So basically by default there are 100 decision trees. So the above random forest, basically if you see here, this given one basically uses the 100 decision tree, and if you want to change it, then we have to pass this n underscore estimator value. Let's say if you want to pass 50, then we have to pass this parameter into this class, right? So this is how does it work, right? So we can change this value. By default the value of decision tree is 100. Now after that we are using this fit method. So by using this fit method we are training the model, right? Now to know the score of the model, we can call this score method on our model object, right? So once you execute it, you may see this is giving us the score of 97.7%, which represent the good accuracy, right, for the model. So this may vary basically depending on which row are selected as a test data while the splitting was done by the train test split function, right? Now to make the predictions, we can use this predict method on the model object. For example, to predict which image is represented by data 12, right? So we have to pass it as a 2D array to the predict method, right? So that we are passing over here, right? So if you see, this indicate that 12th row in the data is the image of digit 2, right? Now if you want to plot this by using matshow, you may see here this image is basically representing the 2 only, right? So it seems that this image is for the 2 only, right? So this is the image of handwritten digit, and hence it may not be exactly look like the printed image. So now if you want to confirm that it is 2 or not, we can print the actual target value, right? So if you print it, you may see this image is corresponding to 2 only. Now, with this, confirm that predicted image by our model is correct, right? So that is the idea.
Let me summarize the random forest concept. So basically this random forest is a model that contain several decision trees. Basically in random forest, it gives the final output depending on the decision tree, the decision arrived from the group of decision trees. Here we use the concept of bootstrapping. So by using the this bootstrapping concept, it creates the subset of data from the main data source. Now the subset can be created with or without replacement. It may have 3 different sampling we can use for for creating this subset. We can go with the row sampling, we can go with the column sampling, or we can go with the combined sampling. Here one more understanding also we have learned, and that is a bagging concept. So bagging is a technique that involves this bootstrap procedure to create a number of subset of data randomly with replacement. So this bagging, basically it is useful to reduce the overfitting, or you may say the variance. We are also having another concept which we have already learned, that was the boosting. So boosting is basically a technique of creating a number of subset of data randomly without replacement. In predicting a value, we should use this random forest regressor class, whereas in classification problem we should use random forest classifier class. Thank you.